In this section, I want to discuss in-band interference spectrum feature of Triumph ES. First, the background. Each transmitting system, being a radio station, a TV station, a satellite TV, a radar, a GNSS satellite, or else, is allowed to transmit signals only within a certain frequency band specifically allocated to it. It is illegal to transmit in a band without authorization. This slide shows part of the US frequency spectrum allocations to different transmitting systems. Each country has a similar spectrum allocation chart. To receive signals from each of these systems, you need to have its specific receiver. For example, to receive FM radio signals, you need an FM radio receiver. And for a TV signal, you need a TV set. And so for a GNSS receiver. The first element in each receiving system is to filter out other signals and allow only the signals transmitted by the transmitter of the system to enter the receiver. When you select your favorite FM station, your radio set tunes its filters to only accept signals from that radio band and reject all others. The radio set filters all out-of-band signals, but if somehow a strong interference appears within your selected FM band, you have no choice but to select another FM station. Illegal and unauthorized intentional transmissions within bands are rare, although recently there are some GPS jammers in the market, which we will talk about them in the next section. Most often, in-band interferences occur innocently to every band. These innocent interferences, called harmonics, are residual signals from other nearby transmitting systems. The damaging effect of these harmonics depend on the strength of the harmonic relative to our desired signal. For example, if you're very far from your favorite FM station transmitter, but very close to another transmitting system, the harmonics of this nearby transmitter may disturb the reception of your FM station. Now let us focus on GPS. Comparing to an FM radio station, GPS is much more vulnerable to interferences within its band for two reasons. The first reason is that GPS satellites are 20,000 kilometers away, while the offending harmonics could be very close to your GPS receiver. The second reason is that GPS band is much wider, and chances are much higher for a harmonic to fall within its band. FM radio stations are about 15 kilohertz wide, while each of the three GPS band is about 20 megahertz wide, over 1,000 times wider. And there are three of them. Include GLONASS, there are 5 of them, and then add Galileo, SBAS, QZSS, and others. The positive thing is that GPS, as well as all other GNSS systems, use spread spectrum signal structure. GNSS receivers, in processing the GNSS signals, de-spread the GNSS signals, which at the same time spreads the interfering signal. The overall process, called processing gain, gives some protection against narrowband interferences. Let me be clear. there are no difficulty with interferences which are not within the GNSS bands. All GPS receivers easily filter out out-of-band signals, the same way as your FM radio blocks out other radio stations and other out-of-band signals. Harmonics within an FM radio station